Hello, trig fans. How we doing this great morning? It's Tuesday morning. So the weatherman said it's going to get a little bit nicer outside, warm up a little bit. Hopefully we can get that. I hope our family and you are staying safe, keeping your social distancing. Once again, it's how we can get things back to normal as quickly as possible so we're not spreading the virus back and forth to people. Hopefully you're keeping your social distance. I miss you guys. I wish you were here in school right now, but it is what it is. If, once again, you have any questions, please feel free to email me any of your questions. We're going to go on to one last topic here today. We will spend the rest of the week on this topic here and just going over types of problems that we have. Initially, it's going to be the first day is a little bit iffy, but after we go through a problem or two, it starts to calm itself down. We're going to go through some problems on the front here. The back side of the notes that I posted will be your homework for tonight. Just try that, and we'll go over them tomorrow. Once again, feel free to email me any questions. And I've tried twice to get like an online thing for you to give me feedback on how things are going online wise. I still can't see them. I am obviously doing something wrong with Google Classroom. So if you have any concerns, please give me comments in regards to how things are going, in regards to it, the pace of the class, the material that we're trying to cover, and how I'm presenting it. Hopefully, I'm trying to present it in a way where if you were sitting in the seats right now, we'd be going over the exact same notes and you'd be doing the exact same problems. So hopefully you being in my class for 9 weeks has made it a little bit easier in regards to how we do things here. But once again, please give me any comments that you have. If once again I start going too fast here, you can slow me down by just hitting the pause button. The one positive thing is I've become more tech savvy in regards to I can't figure out Google Classroom yet and how to get that information out of that. But I've been able to post videos on YouTube now and post certain things, so I'm sort of venturing into the 20th or the 21st century now, and being able to post a video on YouTube. Today we're going to expand our equations in regards to what we're dealing with. Before, we just had the theta or x is equal to inverse sine or inverse cosine of a value, and we were able to find our three general solutions, or the two general solutions and the first three positives. Now we're going to advance this a little bit more into an equation. Okay, this is a function. These are trigonometric functions. They are periodic functions, and we'll take a look at f of x equals 4 plus 3 cosine pi over 3 x minus 2. Now the first thing we should note is that my variable is now x. If our variable is now x, what mode do we need to have our calculator in? That is exactly correct. We need to be in a radian mode. So before we start doing anything here, let's go to our calculators and make sure that my mode is in radians, which mine is. Now, what we have here is we have a function f of x, and this is, once again, we're Americans, so we say this is Euler notation, but if you're in German, this is called Euler. This is Euler notation. It's a function notation. Basically, this is the replacement for y. Y is equal to f of x, and that's equal to this equation. Here's my variable x. What we are looking for in the first problems that we're doing here is we are saying we want to find our function value at a value of 3. So what we have here is this is our x value, going back to our algebraic skills that you learned over there in Dr. Reed and Dr. Clark's class and dealing with the idea of functions. When I have the parenthesis, this is my x value. So wherever I see an x in here, I'm going to put in the value of 3. So rewriting my function, I have 4 plus 3 cosine pi divided by 3, and then we have parenthesis, I'm going to put in my value of 3 minus 2. Okay? Now, what your calculator will do for you is your calculator will click-a-clack this through for you. Okay, what I suggest that you do is do some mental math and do the stuff inside the parentheses first. Okay, this gives me a value of 1. So I have 1 times pi over 3. So we have, well, what I tend to do with this is my value I put here, I put as a coefficient. So I have 4 plus 3 cosine of 1 pi divided by 3. And that you can clickety-clack and type it straight into your calculator. You don't have to do any pieces, parts with it. You can just type it straight into your calculator. So go ahead and type it in. 4 plus 3 cosine 1 pi divided by 3. Close my parenthesis out. And hit enter. And we get a value of 5.5. Okay, so all we're doing, and this is more or less a click-a-clack calculator exercise. Okay, what I want you to do is I want you to hit a pause button. Before you hit the pause button now, okay, I want you to do the second problem here. Okay, so I want you to do exactly the same thing we just did here, okay, and plug in the value of -2. Okay, hit your pause button and do that. When you're done with it, unpause it, and I'll start working through the problem then. So what we have here is we have f at -2 is equal to 4 plus 3 cosine pi over 3 parenthesis -2 minus 2. Once again, doing some mental math here, -2 minus 2 is a -4. -2 minus 2 is -4. And hopefully we can do some mental math with that. So I'm going to recopy this, 4 plus 3 cosine. Now this -4, I'm going to put as the coefficient to pi. So I have -4 pi divided by 3. So what you can clickety-clack it in, and once again, don't do pieces parts. Okay, use your pi button. 4 plus 3 cosine, parenthesis, -4 divided by 3, and your parenthesis out. So we have 4 plus 3 cosine -4 pi divided by 3. Close your parenthesis out, and you get a value of 2.5. Okay, this here, going forward with this is not very difficult thing to do. This is just your x value, this is your x value. You just plug it in, and once again, you can just clickety-clack it through the calculator. Where these problems become a little bit more involved is when we go down here to the bottom. I have f of x is equal to 2, find 2 general solutions in the first 3 positives. This is a little bit more work. So what we are saying here is f of x is a value of 2, and we want to solve for x. Once again, we are in radian mode here. So what we have here is f of x is a value of 2. So where I have my f of x here, I'm going to put in a 2. This is equal to 4 plus 3 cosine pi over 3 x minus 2. Okay, I'm just 4 plus 3 cosine pi over 3 x minus 2. Okay, this is a trigonometric equation that we have to solve. Okay, so if I go through this to solve, I want to get x all by itself. So what we have to do is get everything that's connected to the x over to here. Everything from here over to here. Okay, now once we do one of these, it will be the same process each and every time. The first thing you're going to want to do is subtract the constant over. Okay, we're trying to get rid of everything over here that's connected to the x over to this side. So we're going to subtract the constant over. So we have 2 minus 4, which is negative 2, is equal to 3 times the cosine pi over 3 x minus 2. Our next thing that we come across is this multiplication by 3. Now, go back to algebraic skills. How do we get rid of multiplication? That's exactly correct. We divide. So I'm going to divide both sides by 3. That will cancel these 3's out. Now, I'm not going to sit there and clickety-clack negative 2/3 through right now. I'm going to leave it alone. I'm going to leave it as a fraction. So we have negative 2/3 is equal to the cosine pi over 3 x minus 2. And once again, if I'm going too fast, hit your pause button and then you can catch up. The next thing that we come to is we have a cosine. This is where we have to start doing some work now. Okay, this is more algebraic skills, what you did back in algebra class. Now we got to get rid of a cosine. So I got to think to myself, I'm going to ask myself, what do I have to do to both sides to get rid of cosine? That's exactly correct. We have to take the inverse cosine. Because these will cancel themselves out. Now this is why I didn't have you do this division right now. Because I have the inverse cosine of negative 2/3. Now I could go into my calculator. Take the inverse cosine of negative 2/3. And we get 2.30. .30 is equal to pi over 3 x minus 2. Now, what we need to go back and think about just before we go any further. If I had the equation x squared is equal to 25, and we're asked to solve this for the value of x, well, what we have to get rid of is we have to get rid of a square term. Well, how do we get rid of a square term? We take the square root from both sides. So what we come down to is x is equal to the value of 5. But it can also equal a second value. That second value is a negative 5. When you're solving equations and you physically have to take the square root to solve the equation, you have to make sure you get two solutions, one positive and one negative. So we have plus or minus 5. Because our original equation was x squared is equal to 25. If I take 5 times 5, I got 25. If I take negative 5 times negative 5, I still get to 25. So we get the two solutions then at that point. Now, why did I do that? Because we've just went through principal values and dealing with these types of things. Taking the inverse cosine. When you take the inverse cosine, we come down to two solutions. These two solutions. I have this, which is my principal value, because I got it on my calculator. But when I take the inverse cosine, how do I get the second value? That's exactly correct. It is the opposite. The opposite. So I can also write the equation negative 2.30 is equal to pi over 3x minus 2. So we take the inverse cosine, we got the principal value and also its opposite. Just remember back to what we've done the last few days. Now my next step is to get rid of this pi over 3. Well, what can I multiply by pi over 3 to get rid of it? You're exactly correct. It's reciprocal. So if I multiply both sides by 3 over pi, 3 over pi. What happens if I multiply by 3 over pi? The 3's cancel, the pi's cancel. So we have 2.30 times 3 divided by pi. So you get 2.20. If I round it up, I get 2.20 is equal to x minus 2. And if I multiply it by 3 over pi over here again, I'm going to get just the negative of that. So I have negative 2.20 is equal to x minus 2. Our last step, well, I got to get rid of subtraction by 2, so we add 2 to both sides. So x is equal to 4.20 plus or minus the period n. And over here, if I add 2 and add 2, I get x is equal to negative 0.20 plus or minus the period n. Okay, now, up till now, the period has been 360 or 2 pi. We were in radians, it was 2 pi. It was 360 when we were in degrees. Now we have to think back to when we solved these equations, or when we graphed these equations. When we graphed these equations, how did we calculate the period? Well, the period was calculated by 2 pi divided by b, 360 divided by b. Okay, when we were in degrees, we had this, and when we had radians, we had 2 pi divided by b. Well, our b value is pi over 3. So we have 2 pi divided by pi over 3, which once again we flip and multiply. 2 pi times 3 over pi. The pi's go bye-bye. So we have a value of 6. So we have 6n. And then over here, 6n. Okay, once again, we've dealt with that before. It continues to come back to us. It's like taco night, it just keeps on coming back. First 3 positives. Now we look at our first 3 positives. This one's negative, this one's positive. I can either add or subtract 6. If I subtract 6, this is negative. If I subtract 6, I stay negative. If I add 6, I get bigger than 4.2. So 4.20 is my first. If I take the negative 0.20 plus 6, we get 5.80. And then to go from 1 to 3, we play leapfrog. We add the period, which in this case is a value of 6. So we have 10.20. Once again, if I go too fast, hit your pause button. Let's take a look at the sign. 4 plus 4, sine pi over 4, x minus 9. We want to find our function value at 1. So this is our x value. Okay, it's the same thing we just did up above. Okay, same thing. We want to put in my value of x of 1. So we have 4 plus 4 sine pi over 4, 1 minus 9. One minus 9 is negative 8. And we're going to move that to the coefficient once again. So in our calculator we have 4 plus 4 sine negative 8 pi over 4. So we can quickly collect that through the calculator. And we get a value of 4. If we put negative 4 in, once again, I'll let you do that. I'll give you an answer. You can do that one. You get 6.83. Once again, you're putting negative 4 in. I get negative 4 minus 9, which is negative 13. So I have negative 13 pi divided by 4. I'll let you work on that if you want to. Going down to the bottom here, okay, we have our function value, f of x is equal to the value of 1. So we have 1 is equal to 4 plus 4 sine pi over 4 x minus 9. I guess 4s were wild for me. Everything's in 4s. The process will be the exact same process start out for each one of these problems. I'm going to get rid of the 4 here by subtracting. So we have negative 3 is equal to 4 sine pi over 4 x minus 9. I have multiplication here. How do we get rid of multiplication? We're going to divide both sides by the value of 4. So we can divide by 4, divide by 4. That will cancel these out. And once again, I would suggest you leave this as negative 3/4 is equal to sine pi over 4 x minus 9. And now to get rid of sine, got to ask yourself, how do we get rid of sine now? Well, to get rid of cosine, we took the inverse cosine of both sides. Now to get rid of sine, we take the, you got it, inverse sine of both sides. So we take our inverse sine of negative 3/4. So we can clickety clack through our calculator. Inverse sine of negative 3 divided by 4. Hit enter. Negative 0.85. Negative 0.85 is equal to, I usually leave a gap here because I'm going to have to multiply by the pi over 4 over pi. So I leave a gap there. But now we go back to what we've done the last couple of days. When we do the inverse sine, how do we get rid of how do we find the second value? This here, once again, is the principal value. How do we find the second value? Inverse sine, we also have to take its supplement. That's exactly correct. How do we find the supplement in a radian form? Our supplement is equal to pi minus our principal value. So we have 3.14 minus, now we've got to watch here, and negative 0.85. Okay, we have minus and negative, so we get the old boom ching that we had to deal with. So we boom ching that. So we have 3.14 plus 0.85. If my math is correct, this is 3.14 3.99. So that is our second value. That is our second value. So once again, we're going to multiply by these pi over 4, the reciprocal of that. So we can multiply by 4 over pi. So we have negative 0.85 times 4 divided by pi. Negative 0.85 times 4 divided by, negative 0.85 times 4 divided by pi. Negative 1.08 is equal to x minus 9, and the 3.99 times 4 divided by pi we get 5.08 is equal to x minus 9. Last step, we have to get rid of the subtraction by 9 from both sides. How to get rid of subtraction by 9? We add 9, add 9, add 9, add 9. So this gives me 7x is equal to 7.92 plus or minus the period n. And over here we get 14, x is equal to 14.08 plus or minus the period n. Okay, how do we calculate the period? Well, our b value is pi over 4. That's our b value, so we have 2 pi divided by pi over 4, which means multiplying by 4 over pi. Pi's cancel out. Here's a little trick. It's always twice the number. If I have pi over something, it's always twice that number on the bottom. So the period will be, because we're always going to flip, the pi's will always cancel, so then we have 2 times 4, so we have a value of 8. First 3 positives. Now, take a look at the first 3 positives. 7.92, if I subtract 8, I'll be negative, so I guess a positive there still. But the question is, what's our first positive? Is this our first positive and this our second positive? Gotta watch yourself. Because over here we have 14.08. We can either add or subtract 8. Well, if we subtract 8, we still stay positive. So that will be our first positive value. 14.08 minus this value of 8, we get 6.08. Then my second positive will be this. And then to go from 1 to 3, we add the period. We play leapfrog. We add the period, which is 8. So we have the 14.08. A little bit more labor intensive trying to get through these problems, but I think you can handle these. Just slow yourself down, and once again, if you need to slow the video down, hit your pause and work through the problems and slow yourself down. That is fine. Okay, you have 2 problems on the back of these notes. Okay, they are basically what we've done these last 2 problems here. Okay, what we did here, one for here, and then one down here for the sign. These we're not doing. Those are fairly simple for you to be able to do, hopefully. But the 2 problems on the back side, what I want you to do is just work on those 2 problems. You can look at the front side of the paper and see if you can follow along with what we did. They are set up the exact same way, so work yourself through the problems. Just these 2 problems. Tomorrow we'll come in we'll go over these two problems. I'll have some additional problems for you to continue to work on. Once again, if you have any questions, I'll feel free to email me, throw some comments at me. That is fine. Once again, I'm sorry about the online survey. I don't know. I've asked people and they can't figure out why it doesn't work either. I can't pull information out. So if you want to make some comments in regards to how things are going for you, that would be great, because I really want your feedback. And if things aren't going well for you with respect to this, please tell me, and I'll make some alterations as best as I can. Once again, stay safe, keep your social distancing out there. Just get ourselves back to normal as quickly as possible, and the only way we can do that is everybody cooperate a little bit and keep our social distance. So please do heed those warnings, and hopefully we can get back to some sort of normalcy here sometime in April. Hope things are going well for you and your family, though. Hope things, everybody's feeling well in your family. If you have any questions, email me, comment me. That's it for today. Adios. We'll see you. I miss you guys. I wish we can get back to classroom stuff again. I miss you, but we'll work ourselves through this. You folks have a great day.